Hi everyone, this is Maths World UK. I'm James Grime and today's guest is Zoe Griffiths. Zoe is a speaker. She works with Think Maths and she travels the country and visits schools and gives inspiring talks and workshops about mathematics. So we talked a little bit about what inspired her to study mathematics when she was at school. And we talked also about how she studied maths and philosophy at university, which I was particularly interested in. And today Zoe has brought in a couple of mathematical magic tricks to show us. The first was a card trick, which if you follow the instructions, you can all try yourselves at home. The second was more of a calculator-based trick, which Zoe has left as a bit of a challenge to see if you can work out why it worked. But we started our conversation by discussing how Zoe is using lockdown to study some new skills.
But I've been busy. I've been learning computer coding.
Yeah, you told me. I was very impressed. You said you were learning Python.
I have, yeah, yeah. It's been good.
Have you
Um,
never done that before then?
no, I haven't. I avoided it at university because I thought I didn't like computers, which was a big misunderstanding. Turns out. Yes, it's great. I love it. It's been really good. Sort of doing it like a job while I can't do my normal.
Yeah, because I guess you're like me. You go around and travel and give talks, don't you?
Yeah, yeah, exactly. So I'm often in schools or at events talking about maths, but they're all cancelled. So
And this is Think Maths, isn't it? So, tell me a little bit about Think Maths.
So Think Maths well, it was started by Matt Parker, the stand-up mathematician.
Part
Um,
of his empire,
but yeah, it's part of the Parker
the
Empire.
stand-up
Uh,
mathematician empire.
yeah, and so there's a group of mathematicians who give talks in schools and do workshops, and the whole idea is just to kind of get kids excited about maths.
Well, how were you at school? Were you a good student?
Yes, I'm not gonna lie.
Yeah, me
Yeah, I
too.
didn't get
Me
any
too.
marks,
Yeah, exactly. Yeah.
but
And was it maths that was your number one?
I don't know. I was thinking about it. There was never a time I didn't like maths, um, particularly, but I wouldn't say it was my favourite subject at secondary school. I liked it enough to go on and do it at A level and further maths, so I enjoyed it. But I didn't kind of feel that I was a mathematician or feel that I wasn't really into it. I wouldn't say until sixth form when I discovered that you can kind of do it for fun. Like I didn't realise that people read maths books outside of maths lessons or did maths recreationally or anything like that until I got to sixth form and met some friends who showed me that there's a popular science section of a bookshop, which I didn't know was a thing.
And is that what it was that you noticed? Was it? Do you remember what book it
A
was?
short history of mathematics by Timothy Cowers, which
Oh,
I mean, it is a good book, but it's a good place to start. My friend bought me for Christmas when I was 16, at my first year at sixth form, and I discovered that people read maths books for fun, and because I think I liked lessons in math. I like maths lessons. I like doing well in maths, but I didn't really consider it to be something I enjoyed outside of lessons until then.
is that the kind of thing that inspired you to start doing this for other people? So you were a teacher first.
I was a teacher, yeah. So I did a maths degree. Actually, I did maths and philosophy at university.
Oh, oh, now
And
that's
then,
interesting. You did the maths and philosophy option.
yeah. So I did natural sciences at Durham, which is like a combined science course, and you can mix and match whatever you want within it as long as there's some percent, like above 60% science. So I did like 60% maths, 40% philosophy, something like that. And it was good. Um, but I didn't do any philosophy of maths, which you would think would be the thing to do. You're doing a maths and philosophy degree, but
Yes, that is what I thought you were doing.
um,
So I know people who did maths and philosophy before,
yeah.
but I've never quizzed them about it. I know there's similarities and it's the deductions and the logical thinking, but is that your experience?
Yeah, so I think I enjoyed philosophy because it was about arguing rigorously, all the bits of philosophy that I did, and that sort of just in words rather than in mathematics. And I enjoyed the balance, really, the variation of being able of kind of doing maths and then doing an essay subject as well. Because I like writing essays, so I wanted to keep that up. But yeah, it's definitely there's definitely similarities in terms of it all being about arguments and proof, but in a different with a different method than you would in mathematics.
Have you kept up with the philosophy?
No, I wish I could say I had. Not really. My brother is a philosophy professor. Well, no, an
Wow.
associate professor, something like that. And so he's outdone me by a long shot. And I can't have conversations with him about philosophy anymore.
But what does he know about maths?
Yeah, exactly.
And so then you went into teaching.
I did, yep. So I was a maths teacher. I did a training year and then 4 years of that, and I enjoyed that a lot. And that kind of the satisfaction of kind of showing somebody else your enthusiasm for mathematics, sharing that with other people is where it all started, I think.
Exactly, and I think that's a good place to introduce the thing you've brought in to share us today. So we were talking about things that people can, play with at home or try out at home. So what is it that you've brought in to show us?
Okay, so I'm going to show you some mathematical magic tricks, or everybody's favourite. So tricks that you can use maths to work out why they work, use mathematical thinking to sort of unpick them. I don't think I'm going to tell you why they work. I think that's for you to do at home. So I'm just going to demonstrate the tricks. We can have a bit of think about them.
Sounds perfect. Let's do it.
All right. Okay. Well, I'm going to start with a card trick. These giant cards are not necessary, but they help when you're doing over Zoom. Okay. So the first thing you need to do in this trick is to have 3 piles of 3 cards. So I'm going to put 1, 2, 3 cards there. 1, 2, 3 cards there. 1, 2, 3. And I'm going to be making it really obvious what I'm doing in this trick, because there's no sleight of hand, there's nothing dodgy going on. I'm literally just following an algorithm to make this trick work. And so if you follow the same instructions correctly at home when you have a go, then it'll work for you too. So I'm going to make it super obvious what I'm doing, so that you can follow it. You might want to whiz back and watch it again if you miss some of the instructions. But started off with 3 piles of 3 cards. And then I'm going to ask James, who's going to just tell me which pile he'd like. So would he like the left pile, the middle pile, or the right pile?
I will go for the right pile.
Okay, here we go. And so I'm going to lift up the right pile, and I'm going to show the camera the card on the underside of the right pile. Now I can't see my camera feed, but just in case you don't believe me, I'm going to shut my eyes so that you know that's not how this trick works. There's me shut my eyes. That's your card. Hopefully James can see that and everyone at home can see that.
Got it.
You got it, James? Don't forget it. Perfect. The next thing to do is to take the pile that your friend chose and put it on top of the other 2 piles. So like this, there we go. And so now your friend's card is 3rd from the top, because it was the bottom of the top pile. So it's 3rd from the top. And now I'm going to ask James to lie about the card that he just saw. So to say the name of any other card. Can you do that, James?
3 of clubs.
3 of clubs. Okay, so we've all just seen the 3 of clubs. And so I'm going to spell out 3 of clubs. He could have said any phrase at all, and I would spell it out. But he said 3 of clubs, so I'm going to spell out 3 of clubs. And every time I say a letter, I'm going to put a card onto the table. And when we get to the end of a word, I'm going to pick up those cards and put them underneath. And then when we've got to the end of the whole phrase, the end of the whole routine, we'll see where James's card has moved to in the pack. So 3 of clubs. So I'm going to do T. Oh, you can do it with me, James, if you want to. T. H. R. E. Thank you. And we got to the end of the word. And so we're going to pick up that word and we're going to put it underneath the others. And then of is O. F. That goes underneath. And then clubs, it was clubs, wasn't it? Is C. L. U. B. S. Stick that underneath. Now, the amazing thing about this trick is that whatever card phrase they choose, however long it is, the card they originally chose underneath the pile will always end up in exactly the same position, right? It doesn't matter how long that card phrase is, and this is really counterintuitive. That's amazing. So we're going to see that happen. But before we do that, I'm going to remind myself that James is lying to me, which is despicable. That's fine. So he's lying to me, so I know that that card is false, and false is spelled F-A-L-S-E. And the E, okay, if you follow the instructions correctly, every single time, as long as they say a real card phrase, the E of false will always be their card. Hopefully.
It is my card.
That is your card. Hey, there we go. So it worked. Excellent stuff.
And so that works every time.
It works every time. So often people say to me, oh, well, if I'd chosen a different card phrase of a different length, would you have done things differently? So am I calculating how long that card phrase is and adjusting my algorithm? And that's not what I'm doing. So I'm literally doing exactly the same thing every single time. And that's amazing. And it's amazing that it always works. So as long as they say a real card phrase. So actually the only rule is they can't say joker. basically joker, that's it's not going to work. And so I guess your job at home is to try and work out why that's the case. Why does it always work, regardless of how long that card phrase is? There's a number of things you could do. So actually when I put James's pile on top, I said his card is now third from the top, because it was the bottom of the top pile. So if I turn over that card, this obviously isn't the one that he chose, it's just an example, but if you turn over their card when you put it on top, it will then be easier for you to see how that card moves through the pack, and that might give you a clue about what's happening. So that's a bit of a tip. Otherwise, I think I'm just going to leave it to you to investigate logically, systematically, see what you can find out. Why does this always work? So that's trick number one. You ready for trick number two, James?
I am ready for trick number two.
You're going to need a calculator or a phone.
I have a calculator. Here we go. Here's my calculator. This is a great calculator. This is
I can't see your calculator because I've made it.
It's a proper good one.
Is it? What is it? What's the model?
It's electronic. That's what it is. It's an electronic calculator.
Okay, good. Right, so James has got his electronic calculator, and what I'd like him to do is to type in any 4 digits. Obviously, any 4 at all.
Any 4.
Not all zeros. That would be not fun.
Okay, any 4 digits.
And they can be repeats or different, whatever.
Got it.
And then we're going to mix that up a bit. So I'd like James to, you're going to press plus, James, and then 17. So 17.
Plus
equals.
17.
17, 17. And then press equals.
Mm-hmm.
I know you can add 17 in your head. So there's more coming. So.
Okay, thanks.
So you've got a new number on your screen now, which is hopefully 17 bigger than the last number you had.
It is.
Perfect. Then we're going to mix it up even further. So we did 17 last time. So this we'll do 18. We're going to do multiply. So multiply by 18, 18. And then press equals.
Done it.
Cool. And now you've got an even bigger number on your screen.
Mm-hmm.
Okay. So I don't know if you've got pen and paper there. I should check that before we started the trick.
I can. I've got pen and paper. Okay.
If you could write down nice and big your calculator display, so that, because in a bit you're going to hold it up to the people at home and show them what you got. Not just yet though. Wait a bit. Just write it all out. And actually, while you're doing that, I'd like you to choose one of your digits from your calculator display to be your secret digit. And I'll explain what that means in a second. But one of those digits to be a secret digit, and it can't be 0. So you're choosing a non-zero secret digit. And maybe you could indicate to the audience which one is a secret digit by circling it, something like that.
Okay.
So you've got all of your calculator display and one of those non-zero digits.
And I'm going to pick one to show. And do you want me to show the camera?
Yeah, I might shut my eyes first, actually. Because in the same way I can't see my own video feed, I also can't see James. But in case you don't believe me, I'm going to shut my eyes. It isn't how this trick works. So I'm shutting my eyes. James, if you could show.
This is my calculator answer, and I've circled my secret digit there.
And then can I look?
I've done it, yeah.
You've done it. Perfect. Okay. Right, so you've all just seen James's number at home. I don't know what it is. I've got no idea what 4 digits he started with. But despite that, in a minute, James is going to read out all of his digits apart from his secret digit. And I'm going to tell him just by reading his mind what his secret digit was. So if you're ready, James, go for it. Read out all of your digits apart from your secret digits.
And I can do it any order?
You can do it in any order as long as you don't mess it up.
I'm ready.
If you're confident doing it in any order.
I am ready.
Go for it.
Okay. 9.
Yeah. 9, yeah.
6.
Mm-hmm.
3.
Yeah.
5.
That, I think you have missed out a 4.
I have missed out a 4. Look at that. I missed out the 4. That was my secret digit. So are you going to explain how this works?
Am I going to explain how this works? I think I'm not going to fully explain how this works. I want to leave a little bit of work for people to do at home. But I might give them a bit of a clue. Give you a bit of a clue. So I don't know, genuinely don't know what 4 digits James started with. There's no trickery going on. We didn't agree anything in advance. It is just as you see it. So I don't know what 4 digits he started with, but I do have some information about the answer that he ended up with, given how it was made. Because I know how it was made, because I decided that. And in particular, because he took a whole number and then multiplied by 18, because that final step was multiplying by 18, that gives me quite a bit of information about the answer that he got. So for example, if you take a whole number and you multiply it by 18, then the answer you get must be even. Go and maybe have a think about why that must be true. But there's a number of other things that must be true about the answer you get when you take a whole number and you multiply it by 18. And it's one of those other facts that allows me to do this trick. And then you'll be on the way to working it out. Do you feel like that's enough of a hint, James?
I think that's a good hint, yeah. It's one of my favourite tricks as well. I should tell people these 2 tricks are a couple of my favourites as well. So I love these and I hope people will enjoy trying to work them out. Hey everyone, I'm back just to say thanks again to Zoe for bringing in those magic tricks. I do hope you try them out for yourselves, and I'll put a link to Think Maths in the description. But until next time, I'll say stay curious.